Geometry 1-4, angle measure. So before we get too deep into angle measure, we're going to talk about the parts of angles first. So this guy here, this is called a ray. And a ray can be named in a few different ways, but one thing that's important about a ray is it starts at one point. And for this ray, this is going to be point M. And then we're going to put a couple other points on here to use for reference, point O and point P. And so we can name this ray, ray MP. Notice how the M is first, because that is the point on the ray and not the arrow. It's the part where the ray starts. It can be MP with the ray on top. Notice how one side has an arrow and one side does not. You could also call it MO, right? We could say P or O, doesn't matter. We start with the M is the important thing. We could also call it ray MO. All right. Now let's look at this line right here. So we've learned this. We've learned that this is a line, a straight line here with arrows on each side. But we could also look at it in a different way. We could also look at this as opposite rays, meaning this ray starts here and goes to the right, and this ray starts here and goes to the left. So this is a line, but we can also look at it as opposite rays. One ray would be ray JK, and then this other ray on the left would be JH. Now notice how it doesn't matter if the ray is going left or right. The ray that you put on top of the notation is going to the right. It does, and part of that is that the beginning of the ray needs to be the first letter. JH, ray JH and ray JK. There they are, opposite rays. Next, here is an angle. And we're going to start right here. This point here is X. And then we'll do another point here that we're going to call Y, and a point down here is going to be Z. This point right here, notice how XZ is a ray and XY is a ray, and they are attached here, or they meet here at X. This is the vertex where the two rays begin. Now, let's see, this is side XY. Notice I have a ray XY, and this one right here is going to be side XZ. Now, I should write XZ right here just to be a little bit cleaner. All right, now this angle here, a lot of times you'll see angles, you'll see just like a number here. This is not saying it's 3 degrees, it's just saying this is angle 3. So if you see a little number, that's just so that you can know which angle is being referred to in the question or whatever. So this is angle 3. And we just say, put the angle there, angle 3. Now this angle can be named in a few different ways. And this, for some reason, can be pretty difficult for students. So let's look at some different ways we can name this angle. So this angle can be named YXZ. So let's start that way. Angle YXZ. Notice how we have this point here, then we have the vertex, and then we have the other point, and here's the angle that we're referring to right here, angle 3. So notice that the vertex is in the middle. Now we could also call this angle ZXY. that would be fine. Z, X, Y. Still, we've got the two sides and the vertex right here in the middle. That's fine. Also, since there aren't any other angles using this vertex of X, we can call this angle X. Yeah. Next, we're going to draw some points on this angle here, and then talk about that. So I've got angle S, angle R. These guys are just floating out here. Not angle, I'm sorry, point S and point R. Yikes. Point Q here, point P here. My vertex is point M. Then I've got point N here and point O over here. And what we're doing with this here is this angle. Everything that's in here, this is the interior of the angle. And everything that's out here, this is the exterior of the angle. And that's all we're trying to show here. Now let's look at some examples. Okay, so we've got this big mess right here, and I'm going to give you a bunch of points to put on this diagram. Here we go. Up here, so I'm going to draw an arrow at the end of this. So this is going to be a ray. And this is point A up here. This vertex here is B. Out here at the end of this segment is D, or near the end of it, I should say. At the end of this segment is point E. This vertex is G. This point right here is J. This vertex below G is H. Down here near the bottom, at the bottom is L. And then a little ways from L is going to be K. And then this vertex here is C. Now we're going to, that's all of the points that we're going to label. Now we're going to label the angles. So here, ABD is going to be angle 1. DBC is going to be angle 2. BCE is angle 3. ECK is 4. BCG is 5. And CGH is 6. GHL is 7. 1, 2, 3, 4, 5, 6, 7. We got all of those labeled. All right, we're labeled. Whew. Now, we're going to figure out what is another name for angle GHL. Another name for angle GHL. So we're going to find angle GHL. Here's G, here's H, and here's L. H is the vertex, so I go GHL. So I'm talking about this angle right here. So we can call this angle 7. We could also call this LHG, angle LHG. Another thing we could call this angle H. Although this could be angle H as well, right? Now, I'm gonna have a couple other questions. What is the vertex of angle 5? So now I'm going to find angle 5. That's right here. We could call it BCG, angle 5. The vertex of this angle is where the two sides meet. So right here, the vertex is point C. So that's my vertex of angle 5. Now, let's name angle 5. see if you can name angle 5, and then I'll come back and give you some possible solutions for that. Okay, pause now. Okay, angle 5. Let's talk about a few options for angle 5. Angle 5 could be BCG, angle BCG. Notice C is in the center of between B and G, so that you know that that's the vertex. It could also be ACG. It could also be BCJ, angle BCJ. There probably are a couple other ones, but I think that's enough of that one. Let's do a couple other questions based on this thing. So name the angles that have B as the vertex. So what are the angles that contain B as the vertex? Go ahead and pause, see if you can figure this out. We'll be right back. Pause. All right, see how you did? So here's B as my vertex, so that means here's an angle here that has B as my vertex, and then here's another angle here that has B as my vertex. So this one and this one. So I've got angle 1 and angle 2. Those two, we could also call these ABD, angle ABD, or it could be angle DBC or DBL. DBC. Could also be DBA or CBD, as long as B is in the middle and you've got the sides on either side, you're okay. Last question I have for you. What are the sides, or name the sides of angle 3? Okay, so find angle 3 and name the sides of that angle. Pause and go. Okay, let's see how you did. Pause and go, that's a funny thing to say. All right, angle 3, that's this one right here. So one side is CE, and this is a line segment. It's not a ray, but that's okay. It can still be part of an angle. So I've got CE with a line segment over, telling me this is a segment. Now, I can do segment CB as the other side, or I can say ray CA. I'm going to say ray CA because I feel like it. You're not wrong if you put CB. If you put segment CB, that's totally fine. All right, those are the sides of angle 3. Let's continue on to measuring angles. Now, we have a problem here, and that is that you do not have a protractor. But let's keep going here, and then maybe we can work this out. So angles are measured in units called degrees. And if I were to start here on the circle, let's just start here on this point here. If I were to go 1/4 of this, I would have gone 90 degrees. If I go all the way around, so there's 90, there's 180, 270, 360. So all the way around is 360 degrees. So that means 3/60th of a circle is 1 degree. Okay, that might be confusing, but that's okay. I'm going to grab a protractor. I should have done that before we started, but I can grab a protractor and let me give you some examples of how to use a protractor. So some of you might have a protractor at home. If you'd like to come in to school and borrow one, you are welcome to. I am going to grab, we've got a variety of different kinds of protractors, so here's my protractor box. So we've got these, someone has printed protractors on a clear piece of plastic guy that this kind of protractor actually works quite well. I'm going to use a protractor that you might have gotten, like sometimes when you buy school supplies, like a binder or a backpack or something, a protractor will come with that. I'm trying to find just a small, nice protractor. I guess I'll use this one. So here's how a protractor works. You take your protractor and you find the crosshairs here, and you put that at the vertex of your angle. Sometimes a protractor will have a little dot right there, and that's where you put the vertex of the angle. And then you make sure that this line, see how there's a line here? That line needs to go along one of the sides of the angle. So let's do that with this one. So I put my crosshairs right on the vertex. I make sure that this line goes right along the line of the angle. It could be either line, but I'm doing this line because I want to make it easier for myself. So I put that right there. And then I just read here, follow this up, and I've got, should be right at 20 degrees, but maybe it's not. There we go. 20 degrees. So, oops, there we go. 20 degrees is, so you can see, now let's look at this protractor, because I've got two different readings here. I've got this 20 here, and I've got this 160 here. So what this 160 is telling me is that this angle from here all the way back to this side again, that's 160 degrees. And this is 20 degrees. So if you were to go halfway around a circle, which is a straight line right here, then you would go 180 degrees. So if this smaller side, I can choose, is this the 20 degrees or this is the 160 degrees? Well, this is the smaller angle, so this will be 20 degrees. And this whole mess right here is 160 degrees. If I add them together, I get 180 degrees. So you could look at all of these, and you can see if you add these two together, you'll get 180 degrees. 120 plus 60 is 180, 110 plus 70 is 180. So you just have to choose which one fits here. So this is 160 degrees. We're not worried about that. We're trying to find this 20 degrees. So let's do a couple more. Now you might find when you get to some of these that you can't really see where this goes. And so you have to maybe extend the line a little bit in order to find that angle. I'm going to do that down here with these other ones as well. Extend that ray a little bit. Let's do this one a little bit too. Oops. Okay. So now I grab my protractor, put it right there in the corner. Then I look up here, and this looks like it is about, let's see, 55, 6, 7, 8, about 58 degrees. And then this angle here, make sure I have my crosshairs on the vertex, and then my bottom line on my bottom line. And this looks like 10, 20, 35, 36 degrees. So notice I've got a choice between 44 degrees and 36 degrees. And I chose 36 because this is definitely not 144 degrees here. And last one, notice this is a larger angle. This one is obtuse. This one is not going to be the smaller angle, like 46 degrees. This is going to be the bigger one, which is 34 degrees. 31, 2, 3, 4, 34 degrees. 134 degrees, sorry. There we go. That's using the protractor. Now we are going to talk about classifying angles. So we're going to talk about 3 different classifications of angles here. One is a right angle. And this right angle looks something like this. Usually a right angle will have a little box in the corner that says that this point A here, measure of angle A equals 90 degrees. So this is a right angle equals 90 degrees. Acute angle So I'm going to start with my 90-degree angle, kind of. So this is my 90-degree angle. We're going to call this vertex here B, though. And then here is a ray coming from B. Measure of angle B for an acute angle is going to be less than 90 degrees. So notice here's 90, here's my second ray, is less than 90 degrees. Now an obtuse angle I'm going to start with my 90-degree angle, my right angle. I'm going to call this vertex C, and then I've got my ray coming out like that. Notice this is larger than or greater than 90 degrees, so that means measure of angle C, let me draw that better. Measure of angle C is greater than 90 degrees. So for an acute angle, it's less than 90 degrees. An obtuse angle is greater than 90 degrees. And a right angle is 90 degrees. Okay, let's see what we can do with this information here. So let's fill out this diagram a bit. There we're going to have a point out here, point K, a point up here, L, continue on with M, then make our way down N, and then down at the bottom here is P, and right here this vertex is J. Okay, now I've got some questions here. Oh, I'm actually giving you information. Here's information. Measure of angle LJP is 121 degrees. So measure of angle LJP is 121 degrees. What is the measure of angle LJK? So if this whole thing is 180 degrees, LJP is 121 degrees. So that means what we have left over here, LJK, is going to be 180 minus 121, which is 59 degrees. Okay, now we have to decide. Oh, use a protractor. Bah. Oh, I totally, okay. So I gave you all this information here. Now, is this angle 121 degrees obtuse, right, or acute? Right, acute, or obtuse? So I look at this angle, and this is greater than 90 degrees, so I know that this is obtuse. Now this angle here, this 59 degrees, is this obtuse or acute or right? This one is less than 90 degrees, so this is a right. Not right, oh my gosh. Less than 90 degrees, so this is acute. Wow, lost my mind. Okay, now we're going to use a protractor to measure a different angle. We're going to measure the angle, measure of angle KJN. Okay, KJN. So I'm going to take my protractor here, put it on here, and I'm looking for KJN. KJN is way over here. So this is not extending there far enough, so I need to extend this ray out a bit. I'm going to make sure my bottom line here is on that bottom line. There we go. Okay, KJN is, I've got to decide, do I look at the smaller numbers or the larger numbers? And since I'm looking at this obtuse angle, which is much larger than 90 degrees, I'm going to be looking at the bigger numbers. So I go 140, 150, 159, 159 degrees. So that's just one less than 160. And this, since it's greater than 90 degrees, is an obtuse angle. Okay, so I'd like you, since you can't grab a protractor, I'm going to have you do a little U-try here, having to do with this diagram here. So name a right angle from this diagram. Name an acute angle. And name an obtuse angle. Okay, so look at this. Name a right angle, an acute angle, an obtuse angle. Go ahead and get to work. Pause right now, and we'll be right back. Okay, welcome back. A right angle. So here I've got this box. And so that means that this angle here is a right angle. So MJP is a right angle. Angle MJP. Now you might have said JPN, and that would be okay. Angle J wouldn't work because angle J is all of these different angles, so you don't know which one is which. Now, you also might have done KJM or MJK. That is a right angle here as well, because this is 90 degrees, this whole thing is 180 degrees, so that means this is 90 degrees as well. So any of those answers would work. Angle MJP, PJM, or MJK or KJM. Any of those answers would work. An acute angle. So there are lots of different acute angles here. One is NJP. That's the one I'm going to write down. NJP. You could also do MJN